Wittig or McMurry? This is the question if we intend to synthesize these hydrocarbon olefins, this and that. And as we will see, it makes a difference if we have the same structural units on both sides, or we have different structural units on both sides of that olefin. So let us start with this structure, this cyclohexylidene. Well, a McMurry reaction would mean we have just to start from cyclohexanone with titanium in the oxidation state 0. Titanium dioxide would be eliminated, and we would have in just one step the homocoupling product by a McMurry reaction. A Wittig reaction, well, we would start with cyclohexanone, the same as here, but then we need a phosphonium ylide. And how do we synthesize that? Well, starting from this bromo compound, a nucleophilic substitution, for instance, with triphenylphosphine, then a strong base for the deprotonation, forming that ylide. So overall, nucleophilic substitution, then deprotonation, and the Wittig step itself, a 3-step procedure. There is one alternative. We could also start from the bromo compound, from the bromocyclohexane, forming a Grignard reagent in the first step. Let this react with the cyclohexanone. So addition process, forming a tertiary alcohol, and then an elimination reaction, acid induced, would lead to the olefin, the highest substituted olefin here, this one. Okay, 1-step procedure, 3-step procedure, 3-step procedure. Well, the choice is relatively clear. If you can do a McMurry, you would prefer this one here. Now, to this target molecule. How about a McMurry reaction here? Well, we would need cyclohexanone as one component and benzaldehyde as the second component. Well, how can we avoid homocoupling processes? We would need a cross-coupling McMurry. Well, we cannot avoid the homocoupling. The titanium will preferentially react with the aldehyde first, and then we get stilbene as the homocoupling product of a McMurry reaction with benzaldehyde. So we can cross that out. Well, I've put that in brackets. This does not work. Slightly as a byproduct, but not as the main reaction. Well, therefore, we should try Wittig reaction. Well, 2 possibilities, either from cyclohexanone and benzylic bromide. This works very well since the triphenylphosphine would easily react with the benzyl bromide. It's more reactive for an SN1 process, while here with the secondary bromide and SN2 process, some steric hindrance, it would work, but not as good as this one. So with Wittig, we would start with these 2 starting materials. What about the alternative? First Grignard, and then the elimination reaction. Well, forming a Grignard reagent with a benzyl system is notoriously difficult, since Radical formation is preferred, and then we just get diphenylethane as the product, as we know from the first organic chemistry course. So with magnesium, it would be better to try here Grignard formation with cyclohexyl bromide, then let this react with the benzaldehyde, a secondary alcohol is formed, and in the third step then again acidic catalysis to eliminate water. So, if possible, and this is only good with homocoupling, try McMurry. In other cases, Wittig is the preferred reaction, while it is not that good in atom economy, because you have a lot of waste, especially if you start with triphenylphosphine as for the formation of the Wittig ylid. While, however, one should always think about, instead of the Wittig reaction, that combination of Grignard reagent, addition process of the organomagnesium compound, and then elimination reaction. Thanks a lot.